6.8 Properties of regular polygons. Like we saw last lesson, a polygon is a plane figure with any number of sides in a closed loop. A regular polygon is a polygon with congruent side lengths and congruent interior angles. Now, what does congruent sides mean? Congruent sides are sides with the same length. So every side has the same length in measure. Congruent angle has angles that are the same measure. So they all measure to be 90 or 60 or 30 or whatever. So a regular polygon has the same length sides and the same measure of angles. Similar polygons are objects that have the same shape but different sizes, such as those produced by enlargements. So if one object is the same but only larger or smaller than the other, we have similar. So we can classify polygons as regular, similar, or just simply a polygon. The interior angle are the angles inside a polygon where two sides meet. And of course that meet at a vertex. Couple of interesting properties that we have for polygons. If we want to determine the sum of the interior angles, so if we want to take all those angles of any polygon, and we've got a bunch listed right here, if we wanted to take, say, a hexagon or an octagon and determine the sum of their interior angles, we would take 180 multiplied by n minus 2, where n is the number of sides. Let's try to choose one at random here. Let's do the Pentagon. Now, a pentagon is a 5-sided shape. So let's fill it in right away. Number of sides, 5. And let's draw a picture. Well, 5-sided. 1, 2, 3, 4, 5. When I think of a pentagon, I think of a house or home plate on a baseball diamond. So to get the sum of the interior angles, we would say 180 times 5 minus 2. Of course, that would be 180 times 3. And let's pull out our calculator just for good measure here. Turn it on. Clear it. We can have 180 times 3 to get 540 degrees. So if we took a pentagon and we added up all of our angles, they should add up to 540. Your task, of course, will be to complete the chart. Hexagon, heptagon, octagon, and so forth. Provide the number of sides and a picture of what it would look like. The second property we want to look at is a diagonal. A diagonal goes from a vertices across the object to another vertices. It doesn't have to be direct, it doesn't have to be going through the center, but it goes from one vertices to another vertices, but it can't be the side of an object. We'll take a look at this in a second. Our formula is n times n minus 3 divided by 2. This formula will tell me how many lines or how many diagonals I can draw on an object. Let's turn the page to look at an example. Well, let's start by naming our object. We've got 1, 2, 3, 4, 5, 6, 7. Well, what is a 7-sided object? It's a heptagon. And calculate the number of diagonals. Well, like we said, a diagonal is a line from a vertice to another vertice. So I'll start here. And vertice to one vertice. Diagonal. I could not go to this vertice as this is already classified as a side, not a diagonal. So this one would come down to here, come down to here, come down to here, and of course I would stop because I couldn't do this for the side. I would then go to the next vertice and draw to each other diagonal. And just continue around my object. And of course, once a line is already drawn between vertices, I wouldn't draw a second one. Now you could continue drawing your object and answer this question. It would take you a little while. It gets confusing. I know my personal experience, anything over 6 tends to get a little bit hectic. That's why we've been provided with a formula. N divided by n minus 3 all over 2. Now we said we're dealing with a heptagon. A heptagon is 7. So I'm going to take my n and change it to a 7. 7 bracket 7 minus 3 divided by 2. I'm going to follow some order of operations here, and I'm going to go 7 minus 3 to get 4. 7 times 4 divided by 2. I'm going to take 7 times 4 and get 28 divided by 2. And I know that 28 divided by 2 gives me 14 diagonals. So if I was to continue drawing on my diagram here, I would get 14 diagonals. It would look extremely messy and I might miss one or two. So I would recommend you use your formula. It's not a difficult one. You plug one number in twice, do a little bit of math, and we find there are 14 diagonals in this picture.